Hi everyone, in this episode of Do You Know? We're going to focus on similar figures and similar solids. Now this is actually a very simple chapter, however, some of us sometimes get a bit confused and we end up not being able to do it, but it's actually quite easy. Now we focus on similar figures first. Please remember, when we talk about similar figures, these are all figures in 2 dimensions. That means they are flat on a surface. Alright, for example, these 2 triangles are similar triangles. They are similar figures, in 2 dimensions. Now, the only thing you need to remember about similar figures is this. If the ratio of corresponding sides is A is to B, then you can actually easily obtain the ratio of their areas by squaring this ratio here. So for example, in this pair of similar triangles, if the height here is the base here is 1 cm and the base here is 2 cm, we see that the ratio of the sides, or in this case they're the base, so we can say the ratio of bases is equal to 1:2, right? Then we can easily say that the ratio of the areas of these 2 triangles is actually 1 square to 2 square, which is equals to 1:4. So if the area here is 1 unit, the area of this one here must be 4 units. This is a simple thing you need to know for similar figures. Now, then we move on to similar solids. Please remember, when you talk about similar solids, they are in 3 dimensions. So maybe we can have a cube. Then another cube that is similar to it. These 2 are similar solids. Again, it's not that difficult. The only thing you need to know is this. If the ratio of corresponding sides is A is to B, you can find the ratio of the volumes simply by taking the cube of this ratio. Take note that sometimes in O-levels, instead of asking for ratio of volumes, they ask for the ratio of the masses. Both of them can be found by cubing this initial ratio of sides. So these are actually really the only 2 things we need to remember under this portion of the syllabus. So bear this in mind. These are just some facts for you to take note of. So take a look at it and make sure you roughly know. For example, if you have any 2 spheres, they will definitely be similar solids. And we have written some other things here that you can have a look. Now let's take a look at a TYS example, and then we will see how we can apply these 2 facts that you need to know. So the example is here. Now, the volume of 2 gold spheres are given here. Now, let's remember, we mentioned that any 2 spheres will definitely be similar solids, right? So these 2 gold spheres we have are similar solids. Now, we must find in the simplest form the ratio of the smaller radius to the larger radius. How can this be done? We are going to use this fact because remember the 2 spheres are actually similar solids. So the ratio of the volumes must be a cube to a cube. Now, from here we are expected to find the ratio of the smaller radius to the largest radius. So, you think about it, these 2 things here actually represent some cube to some cube. If you want the ratio of the smaller radius to the larger radius, what we do is, we have to do the opposite, which is to take the cube root. So since smaller volume to larger volume, is given to be 640 to 1250, and this must obviously be in this form, sum cube to sum cube. If I want to find the smaller radius to the larger radius, remember radius is actually considered a side, right? What we can do is we simply take the cube root of this. Okay? Now, but before we do that, I want us to try to simplify this ratio. Okay? So what I'm doing in the first step is not to cube root yet, but to simply make it into a form that is easier for me to apply the cube root. So I divide by 10 on both sides, okay? So that the ratio remains the same. This is still the ratio of the volumes, please remember. Then from here, to get the ratio of the smaller radius to the larger radius, which is a ratio of sides, we cube root. And that's how you do it. Okay? Now, this is the first part. Second part, they ask you for the smaller ratio of the smaller surface area to the larger surface area. So what are we going to be interested in now? We are actually interested in the ratio of areas, right? So even in the similar solids, okay, they have portions and faces where we are interested in their areas. Getting the ratio of areas is simple because the areas can be obtained simply by squaring this ratio. Okay, so smaller surface area to larger surface area. Okay, it will just be 4 square is to 5 square, 16 is to 25. Okay, what am I doing here? I'm applying the fact that the faces of the sphere, okay, when it comes to areas, they must also be similar. So therefore, we use the ratio of areas to get it. Okay. Now, last part. The largest sphere has a mass of 25 kg. We must find the mass of the smallest sphere. Okay, what do we do here? Now, remember now is ratio of mass. And we mentioned that ratio of mass will be the same as the ratio of volume right earlier on. So to do part B, all you have to do is to know that the smaller mass to the larger mass will be the exact same ratio as this. Okay? And they tell you your largest sphere has a mass of 25. So to get the smaller mass, you compare here. 125 to 25 is divided by 5. We just have to divide this side by 5 also, right? Okay, the answer will be 12.8 kg. So the smaller mass, the mass of the smaller sphere will be 12.8 kg.